So in this session, I'm going to explain another aspect of t-distribution, which goes by the name paired sample t-test. Here, I'm not going to explain again the notion of p-value. I'm going to explain the why this paired sample, in which situations this paired sample t-test is used, and what is the corresponding test statistic. The notion of p-value will remain same. That the logic by which we find out the p-value or the lowest level of significance will remain same for other discussions of t-distribution. So here I'm going to explain the situation where this paired sample t-test is used and what is the corresponding test statistic. Suppose now that we have two samples, xi and xj, of similar size. The first sample is of size n, the second sample is of size n. Okay, these are the samples of the same size from different normal populations having two different means. The normal population, the first normal population is having the mean mu x, the second normal population is having the mean mu y. In certain situations, there will be a relationship between the data values capital Xi and capital Yi. And because of this relation, the pair of data values Xi and Yi will not be independent. In such a case, null hypothesis is defined as follows. Now, what is actually being said over here? Now, remember that whenever a person goes to collect a sample, he collects a sample from a particular population, whatever the population is, and this population is, I can assume that population to behave like normal distribution. That is my assumption. It means that corresponding to the central limit theorem, I can say that if I keep on increasing my sample size, almost every distribution tends to follow the normal distribution. Okay, so that my assumption that the large sample from which the small, for the large population from which the small sample is being collected, will behave like a normal distribution. There is nothing wrong in that. Whenever I'm saying sending the two persons to collect two different samples from different populations, suppose I want a data from the population of women and the population of men. I have sent my two collaborators to collect the sample. They can collect the sample from any website, but while collecting, both of them, one of the collaborators have collected it rightly from a particular website or any other source he can get hold of. And the other collaborator, what he can do, he can, to minimize his time or to save his or not, he doesn't want to, I mean, dedicate his time in collecting samples. Maybe he's very idle enough. He can steal the data from his co-collaborator without letting him know. That he can do. So he can collect some of the data, or he can reproduce the data by himself, not collecting them at all and producing it in front of me, the two collaborators. One is honest and another is dishonest. I don't know this, which one is manipulated and which one is real. So what I'll do, I'll definitely going to consider that both the samples, but in the back of my mind, always a particular dilemma will be played, whether the two samples come from the same population or whether they come from the different population. Okay, so that is the thing which is actually played in the case of two population theories, whether my two samples are coming from two different populations or whether they are same population. So at the end of the day, you can say that I'm not actually totally, I know that my collaborators are not totally loyal. So I have to test it. Now, maybe they are loyal, but maybe it may so happen that the two populations are different, but behaving in a similar manner. Then also this case is going to arise mu x equal to mu y, or some manipulations have been done from the part of one of the collaborators. This can also happen. I do not know the logic. So always the dilemma is being played in my mind. So I'm putting it inside the null hypothesis against the alternative hypothesis, which is mu x not equal to mu y. So it is a two-sided test. What is the difference between this paired t-test is that here one particular thing is extra particular thing is there which has to be understood. Suppose in the in fourth semester, when you will be having your maths course once again, and suppose luckily or unluckily, I don't know, I am assigned to teach you, then suppose my strategy is there, I want to test some knowledge of on the course curriculum which you are going to study, because most of the things are here and there, and you can know it very well. Before I present my courses, my particular course, I'm going to test you, and some marks I have obtained. This is called the pre-test marks. Second is, once my course is over, then I'm again going to take your test to check what can I check by doing this kind of experiment. Suppose I have been asked to investigate whether my teaching or my course improves your knowledge on the subject or not. If it doesn't improve, then many things may be the reason. Physical classes are not going on. In online classes, everybody is playing tricks. Teacher is not sincere enough. Teacher doesn't know the subject at all. It's a worthless teacher. Students are of low IQ. So many parameters I'll just be mad can play this role. But I have to test it, whether what is the percentage of students that have improved, and if they have improved, there are other situations may arise. If they improve at all, whether it is because of their own effort or because of the teacher's effort. But in this difficult scenario, what is the main part is that if you carefully observe, the set of people on which I'm experimenting, that is not being changed. The set of people on which I'm experimenting, that is remaining fixed. So my sample of CSE students come from the population of CSE students all over the country or all over the world. You are the sample, you are just the sample of all the CSE students of, say, West Bengal or India, who remain fixed. My sample is fixed. I am pre-testing them, I am post-testing them. I want to find out some sort of connection between the pre-test samples and the post-test samples. So on the basis of that, I am actually saying here, I am playing with two samples, but not in that respect, which I earlier discussed, not separately selected from two different populations. Population of CSE students remains same. I am pre-testing them and I am post-testing them. So therefore, such kind of testing will be different from two population test, and therefore that they are called paired sample t-test. So in this test, what we do, we use this kind of test statistic where capital D bar is the deviation of the two observations. Suppose I have the person I, xi is the value of the person I against some parameter in the pre-test, and yi is the value of the same person against that parameter in post-test. So we are going to find the difference between these two. This difference may be positive, this difference may be negative. The student, after attending the probability class, can deteriorate also. Why? He probably maybe it may so happen that before attending my class, he has some sort of curiosity about the subject matter, and now, as I can see by seeing your performance in examination, most of the students are thinking probably that what a rubbish teacher we have got. He cannot teach at all, he just gives lecture, and the subject is also worthless. I'm not going to study the subject. My goal is CA examination, so I'm going to get some sort of score over there. So a student may think like that. In his case, the deterioration will happen, negative value will come. And another student may be present over there. He can think that, okay, maybe the teacher is not good, but subject is very interesting, so I'm going to pay more attention by myself. In his case, uh, we are going to get the positive value. So actually, being the teacher or being the experimenter, we always actually want the post test value to be higher than the pre-test value, but unfortunately it is not always the case. Here, the null hypothesis is rejected in the same way by which we rejected it earlier in the single sample test. Okay, and this is the formula. So here is a problem for you. Suppose we are interested in learning about the effect of a newly developed gasoline detergent additive on automobile mileage. To gather information, 7 cars have been assembled and their gasoline mileages have been determined. For each car, this determination is made both when gasoline without the additive is used and when gasoline with the additive is used. So see, the sample they have selected remains same. One is without the gasoline and another is with the gasoline. Okay, so that's why it is called paired sample t-test. So mileages without additive and mileage with additive, they have obtained these values for these 7 items. Okay, now the question is, using the above data, test at the 5% level of significance the null hypothesis that the additive doesn't change the mean number of miles obtained per gallon of gasoline. Or for my case, there may be a question like this: using the above data, test at 5% level of significance the null hypothesis that the teaching of the statistics teacher doesn't change the mean number of the marks of the students of CSE. So we have got 7 cars. Mileages without additive can be denoted by XI. Mileage with additive can be denoted by YI. Mileages are present. We need to calculate the deviations. So we calculated it. This I'm not going to explain. It's very simple. You can understand very well. And once I calculate these 7 deviations, we can add them up and we can divide by the total number of items. So di minus d bar whole di minus d bar, first of all we have calculated this, and you know the sum of the deviations taken from mean is always 0. So there is no point in taking the mean of this quantity. So we actually need di minus d bar whole square, the sum of the squares of the deviations. Okay, because the sum of the deviations is always going to be from mean is always 0. It's a formula. From this di section we can calculate d bar, and from this di minus d bar whole square section we can calculate the sample standard deviation. And remember, whenever you are going to calculate this sample standard deviation, you are always going to divide it by n minus 1, because it correctly estimates the population standard deviation. So degree of freedom of the formula which is given above is also n minus 1. So after all, we have substituted all the values and finally we have obtained that our t, the modulus of our pair t is less than the value at 6 degrees of freedom, because sample size was 7 and degree of freedom was 6, and therefore we failed to reject the null hypothesis. Here also you can analyze the p-value calculation just like I showed in the earlier example. And here in this particular case, we have considered, I have shown you the t-test for 2 populations which are not paired. The first example is already done in case of the large sample. Okay, and I just put it inside this note just to show you the similarity between between the formula of the 2 different testings. One is large sample testing, another is small sample testing. I'm not going to explain the problem number 1 because it is corresponding to the large sample test. Let me see just, yeah. but I'm going to calculate I'm going to consider this one, the second one, which is t-test for difference of mean population. Let us read the question first. Okay. 22 volunteers at a cold research institute caught a cold after having been exposed to various cold viruses. Random selection of 10 volunteers were given tablets containing 1 gram of vitamin C. These tablets were taken 4 times a day. Control group consisting of the other 12 volunteers was given a placebo tablets. Placebo means a kind of thing which doesn't have any direct effect to the health, but it is kind of a psychological drug. Okay, so suppose you have come to me and you are saying that my stomach is paining. Please give me some kind of medicine. And suppose I do not have any medicine, and I know that your stomach pain will automatically be gone after some time, maybe because of some after uh, eating your dinner or lunch you have started running, so that's why your stomach is paining, but you are so addicted to the drug, you have come to me and you have asked me, give me a medicine, please give me a medicine. So what can I do? If you insist, I can start look for any tablet like vitamin C or whatever whatsoever, and I can give it to you and say that, yeah, have this tablet. Okay, and your stomach pain will be over, and you are taking this vitamin C tablet, which is not at all a stomach is a tablet for this kind of pain, and after some time automatically your pain is gone and you are saying, yeah, I've got my pain is removed, I have it's not there, thank you so much. But I know that you have been given a placebo. Okay, and right now in this current situation where many of us are getting the vaccination from here and there, Covishield or Covaxin or whatsoever, some people are saying that whether we are getting the real vaccine or placebo, we never know. I watched a movie long time ago in the year 2012. The movie was named as Contagio. In this movie, probably you have also seen. So in this movie, they mentioned about the placebo effect. You can very well, if you have seen the movie, you can recall the scene in which the heroine Marion Cotillard, she was about to leave Hong Kong, but when she came to know that the group, control group from the village were given the placebo, she decided to stay in the Hong Kong. So these are called the placebo tablets. Now you see the main part of the problem is that these 10 volunteers who they have been given the actual drug for the cold virus, and some volunteers are there, 12 volunteers which have been given the placebo drugs. These two volunteers is definitely these volunteers are actually not, they are independent. They are not like paired sample t-test. It is not like that key, okay, 10 volunteers are there, first of all we give them a placebo, let us check whether something happens to them, and after some time, after some day, let us give them the actual drug, then it becomes the paired sample t-test. But here it is not happening. Simultaneously you have considered 22 items into consideration. You have divided into two unequal parts, one containing 10 and another containing 12. 10 items are given drug 1, 12 items are given drug 2, but you never know that whether they will behave in a similar way or not. Okay, so this type of sample is actually an independent samples supposed to be drawn from two independent population. So here in this particular problem, paired sample t-test will not work. So for this, to deal with this problem, I'm not reading out the rest of the problem for you because I'm going to upload the note in the Google Classroom very soon. But let me show you the formula that I have used over here. Now you see one more thing. I have also highlighted this particular thing. Mu x is less than or equal to mu y and mu x greater than. Actually, we know that in null hypothesis we use equality sign. Yeah, equality sign is there, but it has never been mentioned that in null hypothesis you cannot use inequality sign. Inequality sign can be there in null hypothesis, but with along with the equality sign. But if equality sign is not there, you will not be able to use it, isn't it? Now, whenever suppose mu x is the mean effect due to drag 1 and mu y is the mean effect due to drag 2. So three cases may arise. The effect of drag 1 is lesser than drag 2. Effect of drag 1 is greater than drag 2. Effect of drag 1 and effect of drag 2 are same. Now, for same, you are putting it inside the null hypothesis. Effect of drag 1 is greater than effect of drag 2. It is the actual drag, it is the placebo drag, which is supposed to happen. So we placed it in alternative hypothesis. What about the effect of drag, actual drag being lesser than the effect of placebo drag? I have to consider this situation to be more general, isn't it? To be more precise. So I am putting that section in null hypothesis. If you are considering, again, listen to me. If you are considering mu x to be the mean effect due to actual drag, and mu y is the mean effect due to placebo drag, we always want to, actual drag to play far more better than the placebo drag. Placebo drugs are actually useless. So if you write mu x less than mu y in H1, it doesn't have actually meaning, have any meaning. Well, what does it mean? It means your placebo actual drag is not working at all. So you are manipulating by placebo drugs. So we do not want this situation. We want our drugs to be useful. So we have used mu x greater than mu y, and it depends upon how you define your random variables. Okay. And but it may so happen that in population your actual drug is not working at all. Placebos are working. Okay, so that situation has been included. It is not an acceptable situation. So it has been included in the null hypothesis with an equality sign that there is no difference between these two. Why I can't use this, if I do not use equality sign, why I can't use this formula? What is the logic behind it? Because in this formula, there is no, I mean, imprint of this mu x and mu y. Yes, there is. Actually, the form of the formula is x bar minus y bar minus mu x minus mu y by standard error of x bar minus y bar. This is the thing. Now, I'm saying that these two drugs are not, the mean effects are actually different. So there must be some values. But when I assume that these mean effects are same, that means this part is going to vanish. And therefore, under the null hypothesis, and therefore this word under H naught is written, I'm writing this section only. Degree of freedom is actually here is n plus m minus 2. Why it is so? Suppose the sample size, as you can see, the sample size in the first case is not similar to the sample size in the second case. In the previous pair t test, the only one sample was considered. The size was same. Here, the first sample consists of this many items. Second sample consists of 2 more items. Okay. So here the sample size may be different. Now, when you are going to calculate this joint standard deviation for this particular case, now for sample size, for sample having size n, the degree of freedom will be n minus 1. For sample of size m, the degrees of freedom will be n minus 1, m minus 1. So total degree of freedom will be n plus m minus 1, which is n plus m minus 2. So here the degree of freedom is n plus m minus 2, and this is the formula. This is the formula of the standard deviation, where this sum of the squares of the deviations for 2 different samples has been divided by this degree of freedom. Rest is very simple. You are going to calculate this particular quantity. You are going to calculate this particular quantity, and ultimately we are going to get your t. And since here the number of total item was 22, total sample, first sample was containing 10 items and the second sample contained 12 items. The total sample size is 22. So the degree of freedom will be 20, and at 5% level of significance, the tabulated value is 1.725. And this here we can see that the absolute value of this test statistic is greater, calculated value of this test statistic is greater than the tabulated value, and this shouldn't be the case. So we are going to reject the null hypothesis. Here also you can analyze the p-value calculation in a similar manner that I have shown you earlier. Okay, so this is all about which I wanted to discuss with you. One more part of the statistic is I need to discuss with you, and that I'm going to do it tomorrow. Okay, before that you can take problems from a book where you can do calculations on pair t-test and 2 sample test and 1 sample test, and you can read the sections of t-test from the John Freund or any other book of your choice. So you just read carefully and properly, and tomorrow we are going to discuss the remaining section of T along with some other testing hypothesis testing tools. Okay, I think this is so much for tomorrow today, because if I give you something more in today's class, so I shall not be able to give it properly and will not be able to take it properly. Okay, so I have to do it because we have lots of times, because the syllabus will be completed in very fine way, because I am almost done with my syllabus. So do not worry about the completion of the syllabus, that will be completed in time. Anyways, I am stopping here right now, and I am activating the chat box. So if you want to put your attendance over here, quickly put it. And after that, in the previous session, I saw that 51 participants were there, but probably not all the participants have put their attendance. Attendance number of people putting attendance in the previous session is lesser than 51. So some people are not putting their attendance. So if you are not doing this, then you are losing your own attendance. What can I say? So please sincerely put your attendance, and you can leave the classroom. Tomorrow we are going to meet with some other topics of on T distribution. Till then, bye. See you tomorrow. Others, please, 51 participants were there. Some people, I think, you have not put their attendance.